Welcome to our tutorial on how to calculate effect size using GPower software. In this video, we will guide you step by step through the process of determining effect size, an essential component in planning your research study. Let's dive in and understand its importance in your statistical analyses. Effect size quantifies the magnitude of a treatment effect or the difference between groups, allowing researchers to assess the practical significance of their findings, not just the statistical significance. It plays a crucial role in determining the required sample size for your research study, ensuring that your analysis is both robust and meaningful. In this step, we explore the different types of effect sizes you might encounter in your research. First, we have Cohen's d, which is used to compare two groups and measure the size of the difference between their means. Next, there's eta-squared, commonly used in ANOVA, which helps us understand how much variance in the data can be attributed to the different groups. Finally, correlation coefficients, like Pearson's R, assess the strength and direction of relationships between two variables. The type of effect size you choose depends on the statistical test you are using. Understanding these different measures will guide you in selecting the appropriate one for your analysis. In this step, we discuss how to obtain effect size estimates for your study. A good starting point is to look for effect size values reported in similar previous studies, which you can often find in the results or discussion sections of their papers. If you don't find a direct effect size provided, you can calculate Cohen's d or other relevant measures using the reported means and standard deviations from those studies. Additionally, reference meta-analyses can be valuable resources, as they often summarize multiple studies and provide pooled effect size estimates, giving you a clearer picture of the effect sizes in your area of research. By gathering this information, you'll be well equipped to determine the effect size for your own study. In this step, we'll cover how to obtain effect size specifically from a randomized controlled trial, or RCT. To calculate the effect size, start by extracting the group means and standard deviations reported in the results of the trial. Next, you will apply the formula for Cohen's d, which is calculated as the difference between the two group means divided by the pooled standard deviation. It's crucial to ensure that the data you use for this calculation represents post-treatment measurements or changes from baseline. This way, you accurately reflect the intervention's impact on the participants. In this step, we will calculate the effect size using GPower software. Start by selecting the relevant test type for your study. If you're working with two-group comparisons, choose the option labeled Means, difference between two independent means, two groups. For studies that involve more than two groups or repeated measures, you should opt for ANOVA, or the specific test that aligns with your study design. In this step, you'll input the data parameters necessary for calculating the effect size. If you're calculating Cohen's d, enter the means and standard deviations for the two groups accurately to ensure correct results. For other effect sizes, input the required values according to the specific test you're conducting. If you're performing an ANOVA, make sure to include the group means and the total variance. For Cohen's d, remember that a value less than 0.2 indicates a small effect, 0.5 indicates a medium effect, and 0.8 or higher signifies a large effect. How to utilize the calculated effect size for sample size calculations. The effect size you obtained serves as a crucial input for determining the number of participants needed to achieve adequate statistical power, typically set at 0.80 or 80%. Keep in mind that larger effect sizes usually result in smaller required sample sizes, while smaller effect sizes necessitate a larger number of participants. This relationship is vital for ensuring that your study is adequately powered to detect meaningful effects. Thank you so much for watching. Please like, share, and subscribe for more videos.